Hey guys, Jay from Garage, here with Freddy from Spectuning. Freddy brought me into Adam LC's drift program early in the year, and we built an engine. And Freddy gave it hell.
I gave it hell. Adam gave it hell. I gave it hell.
And it survived for the most part. End of the season, some lashes closed up on the intake valves, so it was starting funny. So we're going to examine the engine. It's a titanium rod, BC lightweight crank, custom CP pistons that we provided. The cylinder head is done from Billet Xtreme cylinder head. I build the engine, he tunes the engine. He shares with me an honest feedback on what it goes through, which is pretty awesome because these engines see a lot of heat.
Yep.
Tell him
Pretty much
what you
every
did.
event I'll be like, hey Jay, the oil temps are like 260, and he'll just send something, you know, some long message that doesn't explain anything, but it says it's okay at the end.
Well, what are you gonna do?
The air temps are close to 300 or right at 300 Fahrenheit. The coolant temp is 230 to 245. And on top of that, we run a 200 shot of nitrous.
At times.
So the way I run the control is it has a window from 2800 to 7800 RPM. But if the boost pressure is under 30, it will spray nitrous.
Okay.
So there's a lot of nitrous hits throughout a run. I think I calculated it out to be about a pound, 1.2 pounds per lap.
Okay.
Of nitrous.
So it's an engine that is well worked. At a glance, the camshafts look excellent. Really excited about that. For those of you that haven't been following Formula D, these cars are run on really grippy tires, and at times this engine is wide open, period. So it's not just sliding around. What, you know, my perception of it was just sliding around, tires were loose, and you guys are generating a ton of grip.
And then you got to ride in the car.
My eyes were on the temps because the heat is what really starts to kill stuff. But to watch a skilled driver pilot a car around like that, it was really an interesting time. So let's get to it.
So Formula Drift season, the Pro Series, there's 8 rounds total.
Okay.
And they're split up all over the US. But we do have some pretty badass tracks, like Seattle, where you're on the bank for about 7 seconds long, which I did send you a clip of that so you can like understand how long it's on the bank for.
What's the most challenging track?
I would say the most challenging track has been Formula Drift Utah, due to the fact that we're at about 4,000 feet elevation. So everyone, including us, we're down on power. So for that round, that's when I put the larger turbocharger in.
How big of a turbo?
So it's the Garrett GXR 73.
In precision speak, it's a 7375.
Yes. Yep,
but the R series is their
like drag
most
race.
aggressive.
Yes.
Yeah, that's a neat unit. I'd like to try that versus a precision part. All right, I'm going to come at you with this for a bit.
Yeah. So the challenging track is that due to you're down on power, and then on top of that, you cannot see the edge of the track because Utah is sandy, which is very close color to the track, and you're going relatively fast, 70 to 90 mile an hour vehicle speed. So you're cooking, and you have to kind of guess by muscle memory, look through the smoke to see where the track is.
Who put this on?
Who put this on?
Yeah.
I put that on.
Did you heat it when you put it on?
Yep. I put it in the
Is
oven.
there some lubricant on the
I use like engine
nose of
oil.
the crank? Okay.
Yeah. I use some engine oil on the crank. Is that a sign of trauma that is stuck on there?
Oh, we'll have to look at it.
Copy.
But yeah. It's not a sign of bright, sunny, easy days.
Right.
It's gonna pop.
Mm-hmm.
And when it pops, then we'll be in motion, but That's why I asked if it was dry, because if you put it on dry, it can grab a piece of material and drag it up
all the way.
Yeah, and then it will just be a problem. There it is. I love the moment, like something is going to break or give.
Yep. I was waiting for this whole stand to flip over.
I was waiting for the socket to break. I was not going to hit my head on the corner there because that's how it's going to bleed.
No. So although this engine has seen a lot of abuse and heat, I am very, I guess the word controlling can be that, like, hey guys, this is my team. If you start the engine, it has to idle at least 10 minutes, right? I don't want to get watered down ethanol or water in the oil from it just starting and then just moving it 2 feet and shutting it off. I'm always one of the first guys. So like we kind of have a race to grid. So whenever it's like our turn to go, the sooner you are on grid for practice, you may get 1 extra lap, but that 1 extra lap may be the difference between you winning or losing that round. So I'm very early to get on grid. I'll be one of the first guys there to warm up the engine, warm up the oil, warm up the nitrous. So I'm very particular, like it has to be in this window to go.
How often do you change the oil?
The oil gets changed once per round.
Oh, so only the oil it's got fresh oil at all times.
Yes. Well, we don't change it at the event unless we're prepping it to go to the next track.
Okay.
So we get a fresh oil change and then do the weekend.
Okay. Once per event, not once per round.
Yes.
You don't change oil every time the car goes on the track. You change the oil every time you go to an event.
Yes.
Okay, gotcha.
Yes. So the oil has, let's say, 40 laps on it.
There is not much action presented on the face of the damper. So that's pretty nice.
And then what would cause action? Like a loose bolt?
Harmonics.
Harmonics, just things
Yeah, man,
moving,
there's
rattling.
a lot of things. Like the more the stroke, the more the angles, the more the vibration.
Right, right.
So like, you know, there's guys that don't like strokers because they're hard on cylinders or hard on this and hard on that. Well, they work hard.
Which I used to.
Hard working engine.
I used to be that type of guy 5 years ago when we had some unrelated issues to the stroker, but that was the only thing that was different in the combo. So we stepped away. Then I ended up owning a Mark IV Supra with a 3.4 stroker that Jay built years ago, and it was the best thing ever. I never won a 3-liter JZ in my life ever.
No, it's pretty funny because when Brian talks about stroke and a crank, Crowder, he's just like so all in on it.
Yeah.
And he's not wrong because they work hard.
Yeah. On paper, like a dyno-graph, you don't see that big of a difference, but the real world feel, like light to light, it is drastically different.
Yeah. I have a 7680 on my car right now, and it lights up nice.
And you probably still have to manage the torque to keep the power down.
Yeah, you don't get to just put it all in. Oh, that looks nice. There's not a lot going on. So the washer face, look at the snout of the crank, look at the face of the gear. You know, you get a lot of action on the face of this gear. You can zoom in on that. That thing looks really clean.
This engine saw the rev limiter counter about 8,500 times.
Yeah. Yeah, it's just...
And the rev limiter is at 8,400 RPM on this combo. I would have gone higher in the limiter, but my alternator speed is not quite calculated. And one time I went up to 8,500 and the alternator...
Done.
Yeah, it clocked out.
Yeah, that's... I think that's a thing that not a lot of people think about because, like, for example, our version 1 ATI is turning the accessories faster than a stock pulley.
Yes.
So you're already arguably an overspeed pretty quick. So when you run the engine to 8,000 or 9,000 RPM, all your accessories are going way too fast.
Yep.
Yeah.
And you may get away in that in like a drag car and or street car, but we're living sustained at 8,500 for 15 seconds of a 25-second run. So everything is very high up.
Yeah, no, it's a hard knock life. So we're before TDC. All the pistons are down from the deck. Camshafts are in a spot that we can loosen the camshafts up and start working the head off. And I would like, before we get the belt off, to just check the lash and write it down.
Okay.
So if you want, I'll You can rotate the engine, and I'll make some notes. It's funny, there's tire debris on the engine.
Every time I do a spark plug change, I'll take like the Milwaukee leaf blower and I'll shove it in here and get all
the tire debris out.
And I run all the covers just to keep as much tire debris out of areas it shouldn't be.
Well, it's another thing with these engines because you have what is the air quality that the engine is breathing? You're breathing someone else's tire dust.
Tire dust,
so
smoke,
what is that like?
Exhaust fumes, because you're, you know, arguably sub 1 foot away from the other car.
I'm surprised they live as well as they do just based off of what the engine has access for air.
Yep. So our baseline turbo, or like our flat track, short track turbo, is a G40 1150, which is the equivalent to a 7170 in precision terms. We run that one at about 32, 33 pounds of boost, and it makes a solid 1060 wheel without nitrous.
On a main line.
On a main line.
So 1060 hub.
Yep. And that is at about 1.3 to 1 back pressure.
And you said that turbo doesn't really cross over. It's just always it's always 1 to 1 at least.
Yeah, so that's kind of where it lives, right? If I put it on wastegate, which is like 16 pounds on that manifold design, it's at 1 to 1. Like 1.1 to 1. It never goes under.
Okay.
And then I actually did an experiment once where I took a EGT probe out of cylinder 6. I put a back pressure sensor as close to the exhaust valve as possible. Then I had an exhaust back pressure in the collector and one in the turbine housing, and they were all pretty much matched up at redline. On the spool up, they had a little bit of differences, but they're pretty equal pressure throughout the whole system.
As expected.
Yeah. So with that turbo, we ran I think a 150 shot of nitrous, which is a 73 jet, somewhere around there. And that was a very responsive, snappy, torquey setup, even off the nitrous.
It's funny, I was out in Phoenix helping a guy, and he said, there's 200 horsepower with the nitrous on Adam's car? And I said, no way. And then I talked to you, you're like, it's 200. I'm like, oh my God.
Right. So then for Seattle, which is a very long, fast bank, and in preparation for Utah, which is elevation, that's when we run the GXR 73. That's a 7375 turbo from Garrett, and that's their drag lineup, which does better at higher pressure ratios. That one I ran 42 pounds of boost and a 200, 220 shot of nitrous. I don't know the exact jet size because we didn't have it, so I took a drill bit, drilled it out, and stuck it in the stuck it in the hole.
I want to see this drill bit set that you have. It's from NOS.
No, it's from Harbor Freight, baby.
Oh, it's from Harbor Freight?
Yeah.
Okay. So what is the Harbor Freight has a jet conversion in their chart?
No.
Okay,
No.
all right.
And I never dynoed it with the nitrous on the dyno because I didn't want to burn anything up. So I just took the nitrous table, added some fuel, took a little more timing out, and then shipped the car, and I started poking away at the...
Well, it didn't blow up.
Yeah, it didn't blow up.
Which is, this is... I've had BC titanium rods in my Supra for a few years now. This is the longest durability test that we've had with the tie rods.
Yeah.
Brian and Dustin work very closely with racers, and they said, do you guys want to do this? And I said, well, what happens if it goes wrong? And they said, well, just make it right. And it was that simple, and here we are, proving the product that other guys can go out and do the same thing.
Yeah, I'm very confident in these to do it over again.
Yeah, it's pretty awesome. Pretty awesome. Well, it also gives me more confidence because I've just kind of hung out around 1,000 wheel and, 86, 8,700 RPM.
Which is healthy.
And I'm like, yeah, it's fun, especially with a 18-inch tire. But now I'm like, well, there's no reason why, if at constant duty, this thing's driving around the track at 40 pounds of boost constantly, well, I have quite a bit more headroom than I have a 96 millimeter crank. Have you guys considered going to the 96 next year? Or are you going to stay with the 94?
So we have that option working with BC. We can go to 96 mil crank. I want to, but I'm so happy with this engine package. I'm scared of change because we're not changing the chassis up. We're happy with the chassis. We had a championship winning chassis, championship winning motor package. The driver had a couple mistakes here and there because he's driving at an aggression level where he is having fun and it looks exciting to watch. He's not being super calculated as far as driving a little bit where he doesn't want to drive to win a championship, you know?
Okay,
so like
he's all in.
He's all in, you know, like the car is on kill mode. It's pulling wheelies everywhere. Like, it looks cool. He's having fun.
Yeah.
But I always want to do better. I want to find the next. I want to be ahead of the curve. I want to be in the paddock and say, yeah, I have the baddest 2J in the field, which in my eyes we did last year and we will next year.
Yeah, it was kind of interesting. A couple times you said we have the most powerful car here.
Yeah.
I'm like, oh, that's pretty cool.
Yeah.
Yeah. You were sharing with some stuff that you experienced overseas where the guys are afraid to rev the engine up.
Yeah.
And I thought that was pretty wild because I've been revving them up for a bit now, and they live pretty well if you just have sorted parts.
So I went to Drift Masters overseas in Europe. We pitted with a guy, his name's Spozobs Racing, and they're like, yeah, we don't like, I looked at their tune file just to kind of, you know, give my 2 cents, and their limiter is like 7,400 on a 3-liter. And I'm like, what are you doing? I was like, I go to 8,400 on 3.4, and they go 3.4, we go to 7,000 on those.
Yeah, they're just being overly cautious.
So I don't know what they experienced to have that happen, but
maybe they haven't. Maybe they're just inching in on it real slow.
Definitely.
Or if they, you know, sometimes a lot of people have problems, and when they have a problem, they need a fall guy.
Yes.
So it's easy to, when you need a fall guy, to pick apart and blame it as the fall guy. I mean, that probably the large majority of failures in the aftermarket are failure to diagnose rather than failure of component.
Yes. Yes.
Yeah. That's
100%.
Yeah, because there's pride involved.
Yeah.
Yeah.
You know. And what I enjoy about tuning is if an engine burns down and the log says you up, like you did this,
Beep.
right? I can go. I won't sleep for a couple nights because it really bothers me.
Suicide watch?
Not suicide watch, but definitely like it's a hard pill to swallow for me.
Yeah.
But with engine building stuff, you have to examine parts really closely, look at it, and like kind of spend a full day looking through things, and then you have to come up with a consensus of what happened.
Yeah. And a lot of times it's like, one of the funny things about these videos is, I make assessments live, and then the engine will be on my mind for a couple days.
Yeah.
Because I want to make sure that I'm right, and sometimes we have to go back and make correction, because sometimes things have to sink in,
Mm-hmm.
But that's one of the cool things about, you have a combination of a guy that can tune and a guy that can build an engine, and it's pretty hard to beat when you have those two together.
Right.
So when you guys out in the market are shopping for engines, it's like, well, let's say that you have an engine from someplace, a big box store, that doesn't have someone in-house that can help you be successful. And then you have an engine from a place that has a guy that can actually help you be successful, and it costs $1,000 more for the guy that can actually help you. It's like, well, where's the value at,
Yeah.
In the realm of engine builders and shopping for engines, it's like a little bit of extra money can buy you a lot of experience in a shorter path to success.
Right.
So there's a big value there.
And I have a lot of trust in the engine assembly, and I lean on it hard, and it does well.
Yeah, that's another thing, is trusting the components.
Yeah.
For me, building engines is kind of scary nowadays because I'm building engines that strangers have access to, whereas before I build engines that I would tune. And when you hand an engine over to someone and you don't know their skill set and you don't know the competency of the team around them, they can really screw up an engine quick.
Yeah.
And what are you going to do?
It becomes a ugly blaming game.
Oh yeah. So it's pretty awesome to be able to work for people that are competent and can produce winning rounds.
Yeah.
Good.
You want to talk about this?
Talk about that. It's been through a season of fun.
Yeah. Season of fun. No contact on the back. Bearing is still good.
Yeah. It's a nice
bolt
part.
Spins.
Well, it's made precisely.
Yeah.
It's it's made precisely by people that care. It makes a difference. You start counting margin over quality, and you start making some pretty crappy parts.
Yep.
I have a hard time understanding that people don't really calculate the running costs of problems.
Yes.
You know?
They don't.
There's a path to what you want, and if you take the wrong path to save a little bit of money, you just end up not having any fun. And that is not good, you know?
Mm-hmm.
People screw themselves out of fun. How's that pin look?
Man, there is like, I don't want to say the word fretting because I don't know what I'm talking about, but there is no like action going on there.
Oh yeah, look at that. I think it's looking fresh.
Look how good the gear looks too.
Yeah.
I've seen some like gears come off and they're like the grooves are almost gone.
Well, it's aluminum, you know, and it's hard to anodize it, but the anodizing's living very well.
Yeah.
Yeah, those guys, BC makes nice stuff.
So on the front side of the engine, do you think we're at any component limits as far as oil pump, water pump, you know, stuff up here that can cause trouble? Because I want to rev it probably another 200 RPM next year. It's about 8,600 just to have a little bit broader power band.
The water pump was never designed to be efficient at that kind of speed.
Right.
It's a commuter RPM water pump.
Right.
And then you speed it up with an overdrive balancer, and now whatever it was doing at 7,000, the factory rev limiter before, it's worse off.
Right, at 6,500.
Okay. So then you take it and you keep adding speed. So the water pressure, you know, if the pump isn't cavitating, the water pressure in the block is kind of regulated by the head gasket because it has all those bleeds, the bleed coolant up into the cylinder head. So the water goes down the block, up at the back, across the head, and out of the front. And there's air bleeds in the gasket, but you need more water pressure. So the first thing that you would consider is an upgraded water pump. But to figure it out, like this is one of the things I've learned at Bonneville in the past 6 or 7 years, is when the engine loses control because the surface of the, say the surface of the back of the combustion chamber is not being met with water friction.
Okay.
So the water is not dragging the heat off of those components, and you get localized heating, and localized heating creates runaway conditions.
Right.
So you're not having any runaway conditions. You know, you get those situations where it's like everything was fine and then it torched the head gasket out of it, or everything was fine and it blew a hole in the head where you have like localized heat. So going into next year, we'll probably put one of the water pumps that I've been working on it, and modify some head gasket flow. The oil pump is a whole nother subject because the complexity of the dry sump is likely worth it.
Yeah.
You experience a bit of freedom because you have a lightweight crank, you have lightweight rods, you have pistons that aren't overly heavy for the work. But when we get to the bearings, we'll see what's going on there.
Sign.
But as far as a bolt-on wet sump oil pump, I don't think that there's much to talk about, at least not yet. The market is developing and we need good data.
Now, I have seen a couple teams in the field shatter the pump gears, and then the first question goes, oh, like who did your, like not who did, but do you have billet main caps? Is the line bore offset? And then the response goes, we have stock main caps. Then I get scared and I'm like, well,
I've never, in the States, I've never seen someone shatter pump gears.
Yeah.
I've seen people overseas do it and I don't know what they're doing. The crank has to flex enough that the pump gears touch down.
right.
And when you get into a billet gear set in the manufacturing process, they end up being quite a bit looser to where you give up pump efficiency.
Okay.
It's like when you take a Coyote and you put billet pump gears in it, it makes less oil pressure.
Got it.
That's the way, even 20 years ago working on those engines, they crashed the pump gears out of them because the crank would flex, the block would flex, the pump gears would meet, they would crash out, and you had to put steel gears in them. Well, the tolerances are looser.
Got it. So you give some for some.
Well, do you want less oil pressure or no oil pressure? Because if the pump gears die, you're done.
Yep.
Right?
Yep.
So I think that there's to say there's no opportunity for improvement would be dumb.
Yeah.
I just want measured improvement.
Yeah.
I don't want someone saying I bought an upgraded pump and it doesn't make things better or it makes things worse, because if you increase pump flow, without increasing pump feed, you're going to get into cavitation sooner.
Right.
And you have an engine that doesn't hold a lot of oil. So probably one of the biggest single things is more oil capacity.
Mm-hmm.
That's always a crowd pleaser, because then you have more oil at play.
Mm-hmm.
So if you only have 6 quarts of oil at play, how much of it is stuck up in the head? How much of it is foamed?
Yep.
And how much is it available for the pump to supply and protect the bearings? And those are things that you don't understand until you have bearing failures.
Yeah.
You know, so there's a lot of things. Goes back to like properly diagnosing a failure, because it's easy to point the finger at things, but here you have a stock prepped pump, Tomei baffle, rear sump. The thing sees a lot of G's, sees a lot of RPM. They change the oil often and it's living. So it's like, and you're done at 8,500,
Yeah.
which has kind of been my self-imposed limit for synchronizers and oil pumps for quite
Right.
some time. Because the guys that want to go to 9,000 or 10,000 RPM, the amount of turbo
Needed for that.
needed to actually get that done, because it doesn't have the airflow. So you have to just keep kind of cramming it in there, and it's not great. But the oil pump checks out, synchronizers check out.
Can we jump to the lash? Looks pretty good, right? A little tight,
Yeah.
but is this tight enough to cause the low compression?
No, but we're gonna check for leaks in a few minutes.
Okay.
I would like to show off the cam journals and the cam lobes for a minute, because all that stuff looks really nice.
And keep in mind the oil temperature goes up to 250 Fahrenheit in 2 laps. Like we don't run an oil cooler. We put the Toyota oil filter right on the block. We run 1060 Pennzoil, Ultra Race, Platinum, whatever you want to call it. And this is the result of that.
These are the highly affordable Kelford buckets. So these buckets have a season on them. If we wipe the oil away and get a look at the coating, it's a little hazy still because it's got oil on it. Here, let me get this thing really cleaned up so you can see it. There's a bucket top. BC dual valve springs. And look at the tip of the valve. Not much action going on there, if any. And most importantly, look at the cam lobe. The cam lobe is just gorgeous. It doesn't have any ill marks on it, which is pretty awesome. It's just functioning.
Can you explain what this is on the back of the cam?
It's just the
casting.
yeah. It's just the
Since it has lash, it never really touches
never
down
really
to
touches
start
it,
polishing
so never
it.
wears it. Yeah, you can see where the cam initially makes contact. The bucket right here, just like picking up the lifter,
Mhm.
and as you get near the nose, there's some polishing here. Come over the nose, same mark on the other side, but this stuff looks really nice. I mean, you have to put it in context. This
Yeah.
is not a taxi cab engine,
Mm-mm.
you know. And then this, the cam journals are still mirror polished, because that's how Bill does them, and they just look gorgeous. Yeah. So you're not feeding particulate or contamination through the parts, which, you know, you start talking about like having a pretty clean assembly.
Yeah.
You know, if you have contamination, like let's say that you're a guy that has an oil cooler, and you take your old oil cooler and you put it on your new engine. Now your new engine has the contamination from the old oil cooler. It's like, you know, and there's actually places, if you look in the aircraft industry, they certify oil coolers.
Oh, wow.
Because if you had a small aircraft and you had an engine failure, the oil cooler has to be cleaned professionally. So you can take your automotive oil cooler and send it out and have it cleaned professionally, and then you don't have to worry about cross contamination.
Right. So this is the BC 272 cam.
Yep.
I kind of want to step into the 276 world,
Okay.
but I'm afraid of losing torque, or, you know, on the spool up phase, but I can fill the void with nitrous. I want to test it on our spare engine that's in the car right now.
Okay.
But I don't know that the stock plenum won't be a restriction to that cam profile. Because on paper, the two don't line up, right? The 276 is a high RPM cam. The stock plenum is a
it's more of a runner length thing. I would run them and see if you can lose a little down low to gain some up top. I've run all those cams before, and the 276 is kind of a ringer when it comes to making power. Even guys that buy, there's some large Kelfords and there's a GSC line. Like I tested that the big R2M when they first came out, and it's like not one VE number moved.
Whoa.
It's like, okay, and this isn't, it's not a K series. It's not the arena for killer camshafts.
Right.
It doesn't
cylinder
have
head and all that.
The fundamentals of this cylinder head do not loan itself to big camshafts.
Right.
They're pretty small camshafts. Like big camshafts, like 11 millimeters worth of lift. It's like 11 millimeters, guys. You got K series guys that are 16, 17 millimeters of lift.
Whoa.
That's something we're talking about.
On one of my plane rides back or to Europe, I watched all the podcasts of you and Dave doing the camshaft stuff. And I don't want to say I'm too dumb to understand.
Oh, you're not alone, because it took me quite a bit of time. That dude is, he's on his own.
Yes, he is on his own, but like the camshaftism is great. I love it.
It is.
I love it.
It is good.
Right?
Yeah.
And that's the kind of guy you just want to like drink a beer with, or beers, multiple beers, develop a race camshaft for a JZ, and then just put in a Spintron, put in a motor,
Well, we talked about it, and the BC cam is damn good.
Yes.
The head doesn't really loan itself to do. What are you gonna do? You're gonna pick it up a little bit.
Yeah.
So, and Dave's not really interested in picking it up a little bit. Dave's interested in
big swings.
Big swings. So he's working on some stuff that'll be big swings, but he's not gonna. As of right now, we just talked about it the other day. It's not really worth digging into this because other people are already doing a good job.
Yeah, those BC cams look great to the point where I would reuse this Valvetrain in a lesser of a car.
Yeah,
because I want brand new stuff for every new season.
So previously, I looked at this before I started working on the program. I looked at the Valvetrain, and you guys had some buckets that had knocked the coating off.
Yes.
What's the difference between that and this?
So that engine ran OEM shimless buckets, DLC coated by our good friend Matt up in Connecticut. Yep. So good, well-known DLCer.
Proper DLC.
And then it ran GSC S2 cams.
Oh, so steel cam.
Yep.
Okay.
That was the only difference.
Was the cam coating staying intact, or was the cam coating, do you remember?
I don't want to say like the, okay, so the lobes that look good. But the lobes that did not look good just looked like hammered, Yeah,
like, and that's the thing that everyone has to kind of like accept. If the coating's intact, you're not in a bad place.
Like it was straight metal on metal. There's no coating on the bucket.
Once the coating's gone, you're going to be making metal.
And
so
then
that's cool.
One thing to note was we used the same head builder. Bill did those heads. Bill did this head.
Yeah.
Bill is our cylinder head guy.
Yeah.
The results with him have been great. It is very enjoyable.
Those guys, they're in it for the love.
Mm-hmm.
It's different. You can't be the guy that's in it for the love. Let's see how the thing is leaking. It's cold, but we'll leak it and see what it looks like.
Cool. So these spark plugs are from a podium finish.
So these have been raced.
Yes. These have been raced hard with the 73 mil turbo.
They're not. That one's not hot. Have you seen the guy that's got the camera in the cylinder looking at the spark plug?
No, I don't think so.
I'll have Luis link to his article.
Mm-hmm.
Basically, the spark plug's the hottest thing going on in there.
Oh, okay, yeah.
Yeah, so you can see the ground strap glowing.
That's scary, man.
Yeah. Well, at least it's in control.
Mm-hmm.
Once other parts of the combustion chambers start glowing, it's failure time.
Bad time.
Yeah, that's why it's good to start understanding how the heat shows itself in the spark plug.
Mm-hmm. I want you to critique those plugs like we're not friends.
Yeah?
Yeah.
Well, for starters, they all came out, which means there's nothing wrecked in there that pounded the spark plug into not coming out. There's cadmium present. The coating is still on the plug and the thread. So like once you take the coating off down the second thread, you're generally like, uh-oh. Like that's a benchmark. But you still have coating present on the ring. So there's number 6. That's a hot hole. And you're also using a projected tip plug. So a lot of guys will frown upon that, but depending on your ECU, you may have to run a resistor plug.
Right. I'm scared to go to a non-resistor.
Yeah, it seems like the non-Motec cars really get into a big fuss with non-resistor plugs.
And this is running a 200, 220 shot of nitrous. So this is definitely a good abuse on the plugs.
Yeah, you're not overheating the plug. This one's got some oil sheen on it. See it?
Mm-hmm.
So if you look at the shine between those two. So one is the wettest plug you have.
And then I think...
Do you fog the engine between rounds?
No. It goes in the trailer, literally dirty, on flat tires, no fuel. Like, I could have done a better job at that, but it's midnight by the time we're done packing. I'm giving excuses right now.
Yeah.
And none of us want to work. We want to drink whatever we drink. We did buy a margarita mixer during one of the New Jersey rounds. We found it on Marketplace. So
that's
we want to, like, you know,
that's what you need.
Like, enjoy the podium, car goes in wet, and we deal with it later.
Well, the problem is with alcohol-based fuels is the cylinders are going to corrode.
Yes.
So when you get the crosshatch, the valleys of the crosshatch filled up with corrosion, the seal goes down. Right. So you take the cylinder head off of an engine that's been running ethanol for a period of time or methanol for a period of time, and you look at the bores and they look bronzy. That's corrosion. Okay. It's just like cylinder bore care. You know, one of the downsides, the biggest downside to alcohol-based fuel is cylinder wear because it's less lubrication. Yeah. So you just have to be mindful of, you don't get to run alcohol fuel and then leak the engine and start pointing fingers if you're not really caring for the bores. Right. Because the bores are only going to stay nice so long. Here, hold that. So you have exhaust valves. Exhaust valves on number 1. I see you did your hair for today.
This season has been so busy. I gained 30 pounds.
Oh,
maybe 40.
Oh,
I don't get haircuts.
Terrible. So you're working too much.
Yes.
Who cuts your grass?
The grass people.
Who washes your car?
Duarte's son with his new own car wash business.
Okay.
Yeah.
Okay.
I support the hustle.
That's cool. Same thing, exhaust valves. I know I'm working too much when I'm not cutting my own grass.
I thought you were going to say not cutting your own hair.
Oh, I cut my own hair. Twice a week. Exhaust valves.
So I do have a crankcase pressure on this, crankcase pressure sensor. The peak at its absolute highest has been 1.1 pound.
And how do you tie that to an older data point?
Older data point?
Yeah.
I can like overlay 2 logs.
No, like what was your old engine? What was it like?
I never had it on the old engine.
Okay. Exhaust valves. So we're getting like 50 to 60% leak down so far with air migrating out of the exhaust port.
It's pretty bad.
Yeah. But when it's running, it runs.
Dude, the last round, the engine would barely start. Adam's like, it won't start. I go, put your foot to the floor and crank it. Yeah. It would start. And I'm like, okay, goodbye, little engine. You know?
Oh, you have to add air because it's got too much fuel because it's not pumping well.
Yeah.
Yeah. It's just a pump. So it's like, if once the seal goes away, it's not making the heat, and then you pull cranking fuel out of it or add air.
Yeah.
Open the throttle, you're just adding air. There was an engine at World Cup last year that it wasn't making any compression cranking. It was really neat because when they shut it off, you could hear each cylinder. Boop, 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 boop.
Got it.
But if they got it running, it would run a 5
Holy
to start because the exhaust valves are working. Yeah, by the numbers, terrible. 65, 55% leak down coming out of the exhaust valve. Now the exhaust valves, they see a lot of heat. That's part of their job. So you can get into hollow stem valves, which is a pretty trick thing. It's not a weight thing as much as it is a cooling effect. So they'll either drill the face of the valve, put sodium down in the valve stem, or they'll fill the valve stem from the top and then friction weld the cap on.
Okay. The cylinder head does have the badass copper seats, right?
Yep.
Copper beryllium seats, which helps take the heat away from the valve. Now, we looked over my tune-up, and you say I'm a bit low on timing in the mid-range.
Retarded is the word.
I don't want to say the word retarded.
Timing's retarded.
The timing is retarded.
Yeah. Well, but you're soft on it, but it's living.
It's living.
So you could put timing in it. You wouldn't get near dyno tuning numbers because you have no control of the heat.
Right.
The air temps are over 250. The coolant temps are well over 200. So if you tuned it up on the dyno with numbers that made peak power and you went to the track like that, it would just be dead.
Right.
Yeah.
So in my past years, I would start pulling ignition timing very early on. Let's say at 122 Fahrenheit, 1 degree. 180, 3 degrees. 220 air temp, I don't know, 6 degrees. Very aggressive. But then the driver would complain that it's a dog. Yeah. And the engine doesn't have enough power to finish the second lap, like the second set of battles. So then one day, I was in Steph Papadakis' trailer.
Yeah.
And he was like, hey, how much timing do you pull at air temp? And I go, a lot. And he goes, oh, I pull less than you pull. And then him and I just kind of got on like the same wavelength, and we just started pulling less and less timing with air temp.
Yep.
And his B58 program has been successful. This has been successful. I do think that I probably am pulling too much timing when nitrous hits at peak torque. So like 30, 40 pounds of boost, 200 shot nitrous turned on at 4,000. The ignition timing number is 0. Because like, you know, the stacker multiplier, which is very low.
It's hard to put that into context because of the heat.
Right.
If you had the ignition system that would support it, I bet there's a group of guys that would argue just use more fuel.
Yeah.
And don't change the timing.
I do the same. I start targeting richer and richer, but anything past like 7.3 lambda.
Does it ever misfire from low timing?
Does not misfire from low timing, but if I go in like 7.1, 7.0 lambda, it starts getting muggy and misfiring.
Okay.
So the driver will audibly hear a rich mixture more than a low timing number.
Gotcha. I think we're gonna just put this over on the table and let some oil drain out of it. Oh. So we're gonna stand it up, let it drain.
I got goosebumps, man. I like seeing this.
Yeah.
I mean, it's like, it's your baby, you know what I mean? Like,
yeah.
You travel the country with your race car to go racing against friends and or competitors on track.
I did it in my 20s, man. It's a good time. It's a good time just showing up on the scene and seeing your buddies. And
yeah, you know, like start the event, everyone's high, and then not high. You're saying hi to everyone.
Yeah. There may be a little bit of a combustion chase out here, number 6.
You said chase?
Trace.
Trace.
Yeah, see that?
Okay.
Outside of the ceiling ring.
Mm-hmm.
Yeah. I think that this is a good use case for not only the custom-age 625 stud, but the factory gasket.
Yeah.
Because this engine's seen 40 pounds of boost, steady state, at high temp. And you have a small amount of trace here, a small amount of trace, where it's like, when are you going to do that? When are you going to run 40 pounds for 20, 30 seconds, right?
No,
You're just
Bonneville.
Bonneville.
Yeah.
Right. So when you have a situation where you've blown your engine up on the street in third gear or fourth gear and there's holes in it, or you've gone to the racetrack and you've gone 600 or 700 feet and there's holes in it, that's how far off you are, you know. And it's not a dig, it's not trying to sound aggressive or insulting, but that's how far over the line of safety you may have stepped.
Right.
Versus you have an engine that's lived the season and there's a little bit of combustion chase and the exhaust valves leak and you're like, it's pretty good.
You did good.
Yeah, you did good, because when you start blowing holes in this thing, like, see this right here where it's clean?
Yep.
So this area, when you start to overheat the cylinder head, this is kind of a melting point. So when you take your JZ head off and this little pad between the exhaust valves looks porous, you've overheated the material, just like you're burning the head up, just like when you burn a piston up. So it's like, you know, you don't have a lot of action going on here. You know, this is not a lot of action.
No.
You know, and for the boost level, it's like, okay, you know, but you run it rich. The fuel is a coolant. You know, that's one thing that you have to kind of keep in mind is the
And I run this at just 7.4 lambda, all boost, and then on nitrous the target 7.2.
Yeah, but if you look like to get it to detonate, if you bring that up to 8.2 or 8.3, it'll just blow up.
Yeah.
Yeah, because it'll just lose control of itself. So see that little tiny bit of action right here, this little dark?
Yep.
Yeah, it's not much. It's not worth like fretting over, but something has happened there. The cylinder head has T-bolt washers installed in it.
Yes.
So when you torque the cylinder head down, just like you would with a cast pawl, there's no chance of the washer rotating. So you get a pretty equal clamp across the deck of the engine, which definitely helps for sealing.
Would you say this is a sign of leakage?
Well, examine the ring. You know, like examine where the head is actually sealing.
Right.
And see how much is going on. You know, like you can see the cutter machining marks, but you don't have a measurable problem going on. You got heat. You know, there's heat present.
Okay.
Like, you know, you take the engine, put it in the machine to deck it, how much will it take to get flat again?
Yeah.
Because it's only flat once.
Yep.
You know, once you run it, it's not going to be perfectly flat again. It's an OEM engine, and you know that would make an argument for the Dart, because the Dart has 750 thousandths of deck, but then you don't have coolant in that first 750 thousandths where all the heat happens. So you know when you look at, like, you take an engine that's well used and you hone it, you'll get shadows in the bores in the top 3/4 of an inch, because that's where all this distortion, that's where the combustion is taking place.
Got it.
So you make that area thicker and stronger, so there's less distortion, but then there's less cooling.
Right.
So hot gets hotter. You know, you can get if you really get to overheating one or running it where the cylinder is getting hot, like in the areas that it's just solid material, like this is a pillar of material. Like you'll get discoloration in the bores from it overheating.
Can you hurry up and make a badass oil pan?
And I'm quite a bit of money into it already.
Cool.
To be honest with you, it's a cash flow game most of the time. But I've it's been drawn. It's just getting a production process that leaves a reliable solution that is an actual benefit, because like a billet lower pan is a lot of money, and it has seams that can leak,
Yep.
So it's not the approach I want to take. And the guy Tommy that does it already, like, he does a good job with what he does. So there's no sense in like getting in his space with another billet product. But the stuff that I'm working on will be lower cost. So hopefully it'll be something more people can afford, but still be a actual benefit. I don't want to make stuff that doesn't work.
Right, same. Man, your glue game was strong.
Subaru glue strong.
You know what's a flex? This thing had no leaks.
Yeah.
No leaks. Look at that, dry.
It's a Japanese engine.
Yeah.
It shouldn't have leaks. Well, it's a Toyota engine. It shouldn't have leaks. I guess some of the Jap engines leak. Toyota silicone is nice, but it is really work to get it cleaned off. And
I like the color of this.
It gets like in the grain of your skin. You know, it's really messy to work with. Versus this stuff's pretty easy to deal with.
Brother, you have a 2-foot pry bar right now.
Yeah, it's all good.
Uh-oh.
Paint.
Paint.
That's paint off of the camshaft.
Yes, it is.
Yeah. Yeah, it's an uh-oh at first until you look at what it is. It's yellow.
Yes.
Save your uh-oh for later, baby. You may need that uh-oh, but not right now. The pickup is broken.
Oh, there's the uh-oh. Wow.
Doesn't matter if it's submerged, but it has
Yeah, that can pick up air if it, sloshes.
well, this is the screen, right? So the actual tube is in one piece, but the screen was just held in place by the baffle.
Okay.
So it's not if the pickup tube was broken,
There, yeah.
big problems.
Okay.
But this is just it's probably got like little tiny welds and it's a thin piece
vibration.
and it broke. Yeah.
Interesting. Have you seen that before?
Nope. No, but who's to say that it's manufactured by the same place that's always manufactured it?
Right, exactly.
You know, like these are old engines, so some of the parts are going to get passed to other suppliers.
And this was a brand new Toyota like oil pan kit.
Yeah.
We start from.
Yeah, it just broke out of here.
Okay.
Now the bad news about that is when it broke, did anything from its seam get into the oil pump because you're past the screen.
Yep. Well, I'll make note for next year. We'll kind of tack weld that a little stronger then.
You can't.
No?
Nah, it's coated. You'll just make a mess of it.
Copy. Hear me out. JB Weld. Belzona 1111.
Gosh. 5200.
5200.
Yeah.
Is that the sauce right there?
5200 is in the boating community. It's like you could pretty much put anything together.
So I know you and I talked about potentially bumping up the compression.
Yeah.
I feel like if we go up in compression, we will get a broader, better power band, more snappy engine on the dyno. But I feel like with the more compression in it, I have to run less timing, which will lead into more EGT.
I think that you're going to run, I think that if it were up to me and I had the opportunity to swing at it a little bit, I think I would move to a 96 millimeter flat top.
Okay.
And it would, it'd be around 10.8 or something and see how it lives.
Okay.
If it lives, how it lives. Like, let that be the next round. Because the other guys on the other teams are going to be looking for more in their off season too.
Yeah.
And what you don't want, like you're being fairly cautious with your tune-up.
Mm-hmm.
So cautious that you haven't torn anything up.
Yeah.
So that kind of lets you know that you're on the soft side. You know, what would it be worth to make 100 horsepower more, but have to service the engine mid-season? Is that a deal breaker for you?
I don't think so. Like, there are teams that have and or do swap the motor halfway through the year. I wouldn't be mad about it.
But what if you that? And I'm not saying that's how it's going to be, but that could be the case. So you have to decide on whether or not that's worth it to you guys.
Yeah.
You know.
I do enjoy. This sounds kind of bad. I do enjoy being on the upper edge and or like upper limit where other guys are going to try and chase, and they're going to experience potential failures trying to chase us.
Yeah.
You know?
Yeah.
Not sound like...
It sounds a little bit... It sounds some kind of way, but I understand what you're saying.
Not trying to be cocky, egotistical, like, just like... then it becomes a battle of like, well, not a battle, but it's competition outside of competition.
Yeah. Well, it's a little bit of a head game too. When you show up with the most powerful car and everybody knows it, it does give someone the upper hand, you know?
Yeah, yeah.
And if it lives.
Mm-hmm.
You know, if you have the most powerful car and it's dead, then you don't have a benefit. It wasn't going to fall off.
No, I don't think so.
5,000 is the end play right now.
Is that what you set it at?
4.
Okay.
They all, like, I let them leave at 4. One of the cool things about working on the same engine all the time is, like, they all get the same numbers.
Mm-hmm.
It's just like, it's pretty easy like that. Because as long as you nail your numbers, you got nothing really to worry about.
Yeah. Would you say it growing that little amount is normal?
Yeah. Yeah, man. It picks up 1,000. It's 1,000s, you know what I mean? It's like thickness of your hair. One thing that was pretty interesting to me when I took apart Adam's first engine that he brought me was the amount of vibration that was present on the back of the rod bearings.
On the back of the rod bearings.
Yeah, there's and on the parting line of the cap.
Mm-hmm.
A lot of activity, a lot of vibration, a lot of shaking going on. Just life. That's, you know, another thing that people want. They want some sort of pinpoint answer on some things. It's like, well, this engine is now flywheel horsepower is probably near 3 to 4x what it was when it left Toyota, right?
Yeah, that's impressive.
So it's like, well, how is it living? It's like, well, it's living pretty good, you know. Yeah, there's less than that was on the steel rod. So you're through the coating.
Okay.
You know, you have the direction change. This is when the rod is pulling back down.
Mm-hmm.
So this isn't combustion. This is the bottom.
Right.
This is decel stuff.
Got it.
Yeah.
Do you see more decel wear for what the engine's used for?
Yeah, like a drag car.
Mm-hmm.
The land speed cars will get this too. The cars that decel in gear.
Got it.
But ideally, you don't decel the engine. Oil wedge is busy on the other side.
Got it.
You know, like you'd like to keep the oil, the oil timing. You know, the oil is timed through the crankshaft.
Okay.
When it disperses, when it picks up, when it's relied on, and when it's used.
Okay.
You know, and it just get 2.5 thousandths of oil clearance, and it sheds out in between the rod and the crank. Let's see what we got at the. See if you look at the rod.
Mm-hmm.
Get this out of the way. Same thing. Oops. Oh, just throw that thing right on the ground. Wow, there's not a lot of ring tension. They slide right out.
Dude, the line coating is
I know.
there.
Oh yeah, it doesn't. That coating is super nice. The top ring is closed up. See it sitting there?
Mm-hmm.
It's heat.
Not a lot of tension left in the ring.
Yeah. Yeah, it about fell out when I bumped it with my finger. But you can see, like, organically the...
yeah, look how much...
See this?
Yep.
And then see this, how it's just hanging out.
Mm-hmm. It's not stuck, right? It's just
No,
hot,
it's
so
not
lost.
stuck. It's just lost its tension. You have to... we need to find a way to regulate the air temps better.
Yes.
We're lucky it's not dead because of temperature.
Mm-hmm.
But we won't always be so lucky that it won't die from temperature. Did you guys do a cranking compression test?
At the start of the year, it was about 145, 150 across all 6.
Okay.
And near the end of its life cycle, I was in the 90s.
Yeah.
Yeah, I started.
I think that if we see that consistency, when I grab the ratchet to turn the engine, it turns really smooth.
Yeah.
It's like there's less ring tension.
Oh, I mean, even guys on my team will look at me and they're like, "It cranks weak," and I'm like, "I know," But I train my guys to listen for that too.
Yeah. Well, that's straight heat.
Yeah.
Yeah. You have the fuel can only manage so much heat.
So we've managed the heat well enough to not melt down, but we have stressed components out.
Yeah. It's interesting that the blow-by didn't change a lot.
If
yeah,
the
this
oil,
one's closed up too.
The oil was not overfilled, it would not push any oil in the catch can.
Yeah.
That bearing looks...
Oh, it's mostly the dark stuff is the coating.
Okay. Oh, because these are...
Cleveite.
Okay.
The large majority of the advantage in coating is to protect you when things are going wrong.
Right.
So I've used that calico coating before. It's nice stuff.
Mm-hmm.
I think that the King coating is probably the neatest stuff on the market. But if it's if the bearings come out of the box and there's a big variance in a box of bearings, you can't use them.
Yeah, you have to buy 4 boxes.
Man, I've got a shelf of them. It's just not a great subject. But who knows what they're going through? They've got manufacturing in areas that there's war, for God's sakes.
Man, I'm very impressed with the skirt coating.
Yeah, the skirt coating is awesome. It's nice stuff.
Because you expect it to wear a bunch more. Like you've seen a Wiseco piston with their skirt coating, it's almost gone.
No, it's different because
this is different. Yeah, this is a braidable coating.
Yeah, I think it's the best stuff. I mean, that's why I use it. Mm-hmm. The engines take longer to build. The coating takes longer to get done. On and on and on. It's not good for making money, but it's good for a finished product.
Yes.
Yeah.
You can stock a few.
Get $10,000 in pistons on the shelf real fast, just for your own stuff.
Yeah.
Every box is well over $1,000. Yeah, that top ring is closed up, dude. Yeah. Let's get these out, and we'll get a look at the. We're gonna put some rings back in the bore and see what they look like. Look at that right there.
Yep. What hole is that?
That's your timing line.
I'll punch you.
I think it's like top dead center, but it's right there.
Yeah.
It's just off 12 o'clock. That crank feels really nice. Does the bearing have the same amount of crush? Like when you slide the bearing in the rod, does one feel different than the other? Because that's the next stage, is you'll start to close the bearing up a little bit and it'll lose crush. So you pop the bearing out, put it back in, listen to how it comes out.
Okay.
Yeah, it's lost some crush. If we go grab a new bearing and pop it in this rod, you'll see the difference.
Copy.
Like, it just falls into place. Eventually it will start to close. But that's another kind of like old man metric.
So, I don't know if I don't like this. I feel like I don't like this.
Well, no one...
Seeing the timing mark there.
Well, it's not a... Listen, man, if you get the blowing stuff up, it's gonna be back.
Right.
You have hot air temps.
Very hot.
You have a hot engine, and you have ethanol fuel. Mm-hmm. Like you're doing a good job. It doesn't have holes in the thing. You know what I mean?
Yeah.
But it is doing a lot of work in ill conditions. What is the air quality? You've dynoed in a dirty dyno cell before, right? Mm-hmm. Where the engine's eating its own exhaust and it just won't run well. Yeah. What do you think this car's going through on a track where it's eating the other dude's exhaust and tire smoke?
Yeah.
It's like
these engines see a lot of abuse.
Yeah, it's not it's not like they're not dyno queen show car deal. No. The thing's getting work. Man, all the main saddles are still very tight. That's nice. I think this engine's doing pretty good. I think that the ring deal, it's temps. We gotta figure out how to manage that better.
Mm-hmm.
Yeah, so you have like a little bit of fretting,
Mm-hmm.
but as you work the saddle, the cap will get loose,
Right.
and the caps haven't relaxed, but you do have some fretting. Less than a thou. That's pretty cool. Long part, a long, lightweight crank. It's got less than a thou.
That's impressive.
Very impressive. The stock cranks don't keep shape real great.
Interesting.
You'll take a stock crank out of a. That's another thing, like cost benefit. Like, if you have a 1,000 horsepower JZ, you know the crank band's 2 or 3 thousandths of an inch.
Mm-hmm.
It's a problem, right?
Where do you start seeing the stock crankshaft causing some drama?
You know, if it's a coffee and pulls kind of guy,
Mm-hmm.
he'll run it for a couple years, and the crank will be bent, but the bearings will look okay because once the crank is back up on the oil, it straightens itself out.
Got it.
But the end bearings will always show some witness. So like your end bearings don't have much to say. So let's pull this out. Let's also look at that.
You can still see where you measured the bearing and the bearings.
Yeah.
That's nice.
Well, this coating is plastic, man. It lives really well. The problem is the manufacturing tolerance. But I would use this bearing as my primary if you know once they get their clearances right, like its production tolerances.
It's just still impressive. You see the witness mark from your dowel bore gauge? No.
Yeah.
Is that what it's called?
Yeah.
And if the crank was bent, you would see a bit.
Well, it'll like do this. It'll be here and here.
Like offset copy.
I think it's so closed up I can't get it off. It doesn't look like it's butted. It hasn't butted.
Okay.
But if we go I'll go grab a new ring real quick just for comparison. So, kind of caught my eye coming apart, but you could see that the ring has closed up. It's lost tension. So, it's just a temperature thing.
So now, question.
So this one has all this spring in it, and this one just doesn't. It's pretty wild that they're all there.
All there?
Well, they all look the same.
Copy.
Yeah. You know, I've gone 6s with these rings, but temperature control.
So let's say like in a drag car when you used to go 6s
Yep.
with these rings,
Yep.
how long would you go until you would see a ring in that state?
You wouldn't.
You wouldn't.
You wouldn't
Nothing
overheat
at all?
it.
Okay, got it.
Yeah, you're overheating the part.
Yeah.
You know, it's a there's use and misuse. You know, if the part isn't overheated, it doesn't lose tension.
Right.
So you have to kind of keep that in mind. You know, as you're assessing the part, you can say like, oh, that part failed. It's like, okay, ... Why? Why did the part fail? And if the part failed because of misuse, then you try to correct the misuse. You know, it's like there's cycle failure and heat failure.
Got it.
You know, so is it failing because of the action it's being put through or the heat? I think it's in there pretty good.
It's not a good sign.
Oh, let's just peel that edge up, put it in the vise. There it is. This is what's holding it in. because it's rolled that lock edge up. DLC takes the form, it just takes the form. It's a coating.
Mm-hmm.
So feel this edge of the pin and feel this edge of the pin. The edge of the pin that doesn't have that, the edge of the pin that has the edge stood an edge up in the part.
Mm.
So if they would have broke that edge a little bit more and just had a slight radius, then it's not going to be digging at that material. If you DLC coat something rough, it just becomes a really cool cutter.
Yeah.
So they needed to take that edge off a little bit. The pin bore looks fine though. It's just polished,
Which is not a bad sign, right?
No, it's how these things work. This pin is really hard to bend, and to be clear, in operation, it doesn't matter that the pin doesn't fall out of the piston. It matters that the pin floats well in the piston. The having that edge at the lock doesn't matter in operation. It's just an inconvenience when you take it apart. But I was curious about the rod, because one of the things that gets talked about with titanium is how the rod interacts with the crank. And when you get into like a V8 engine that has just a bunch of kind of ill angles going on, things V8 engines do, the rods will get into the rods and the rods will get into the crank. Mm-hmm. And there'll be wear present on the sides of the rods and the witness and the sides of the rods on the crank. So one of my things I was curious about inside of this engine is whether or not we'd have any of that going on. And if you look at it, you have little tiny mark here, little tiny mark there, a little bit bigger, a little bit bigger.
Is that normal? Would you see that on a steel rod?
Yeah.
Okay.
Yeah. But whether or not it can materialize into a problem is always your question. You're always going to have things moving around inside of an engine. But you could also make adjustment for that. Like you'd say, like, okay, that's the action we got at 15,000 side clearance. We're going to open the side clearance up and see if the action goes away. This, to some degree, it's a beta program.
Yeah.
Yeah.
And
Titanium is really strange to machine. A lot of this that you feel, it was present during machining. Like when you take a titanium rod, and I've done it with BC rods, I've done it with cryo rods, as the mic is passing through the big end of the rod, you can feel the mic on the surface of the machine part. And then the steel rod is much more like a gliding action because it's a little toothy. When you zoom in on it, if you zoomed in on this, you'd be like, whoa, but...
Got it.
Titanium's funny.
It is.
But I did an LS7 last month, and the rods, how the rods were getting into the crank, it's like things are flexing
like factory LS7?
Yeah. You could see like it was a troubled engine. So one of the things that you hear a lot about with stroker engines is that they scuff easily. And there's rod stroke ratios and angles inside of the engine. All that stuff should be respected. This engine with the skirt coat, the skirt coat is thick. It builds a layer on the piston, and then as the engines run, the excess will wear off and it will kind of take shape to the bore, an ideal shape to the bore. And if you look at this engine and you look down the bores, there's no scuffing present, which for those of you that have been around the JZs for a bit, you're making over 1,000 horsepower. There's video of this thing just wide open throttle on a lap, and it's not scuffing. And the coating, with how it's wearing in, is offering this very uniform boundary layer of oil that creates a bigger thrust footprint. So what you get on a regular piston, an uncoated piston, or a piston that's coated with a conventional approach, is you get a thinner thrust heel. So the heel of the piston. So imagine instead of standing on 2 feet, you're standing on 1 foot. You've got a pressure point, and that pressure point causes scuffing in the bore. And when you look at the bores on this engine, it's not scuffing. So that's a testament to the coating. So the coating's really neat stuff. It does cause a bit of a timeline delay, and I try to get ahead of it. But if you buy one of my 1600 series engines or above, you get this line-of-line coated skirt, and it does a real good job of keeping oil present and keeping the cylinder from scuffing, because once the cylinder scuffs and it's smoothed out the crosshatch, now there's no oil reservoir there. And when there's no oil reservoir there, there's no way to keep oil there, and that's when you're going to start overheating the piston. That's when you get that dark abraded area on the piston. It's kind of the beginning of the end. But at a minimum, just in regular bore health speak, scuffing is bad, and the coating helps keep you safe from it. So I don't think this will be another A squad engine. No. This engine will go, anytime you're racing for a championship, or it absolutely matters, you start with fresh parts. So the crankshaft looks excellent. The connecting rods look good. The pistons will not be reused. They can go into a test engine. They can go, Adam can give those things away in a raffle or something, whatever you want to do. But this next engine will be, I would prefer 96 millimeter Brian Crower crank, titanium rod, flat top. Yeah. I think that'll be a pretty mean piece. And then we'll work through some ways to mitigate the heat, because the heat, overheating parts, the ring isn't butted, but it's lost tension.
The ring, and then also the exhaust valves are leaking.
You know, I think that we can look into it, but some of it's just life.
Some of it's life.
You have a high output turbocharged engine. Exhaust valves live a hard life, and anyone that tells you different, I don't know yet. In my experience, exhaust valves leak first.
Got it.
And you just, if you're not, a lot of guys blow holes in things.
Yeah.
So when you look at it, you're
not bad.
Here we are. The engine's out on the bench. It's all apart. We're zoomed way in.
Yeah.
What we're forgetting in the moment is this engine successfully served you guys for the season.
Yeah. I would say this is normal wear and tear.
Yeah. Well, it's not normal wear and tear. We want to get ahead of this ring.
Yes. Yeah.
We want to get ahead of the ring at a minimum. Maybe I can get Bill to take the cylinder head apart with me and look at it, and I can ask him, like, well, what would you do differently next time?
Yeah.
But you have a lot of temperature, and temperature is, one of the main things. If you have a good tune-up, and the tune-up is competent, the computer is competent, fuel's competent, everything is done right. What's coming for you is the heat.
Yes.
So we need a better way to control some of that heat, because the inlet temps are hot and the water temps are hot, and we need to figure out how to regulate that to get more longevity out of it. But again, it's not a bad engine by any measure.
No, I'm very happy with it.
Yeah.
It did its part. It showed its face, what it can do.
Yeah. I hope you've enjoyed the video. If you have any questions about this engine, any of the components involved, or any of the other things that I offer, feel free to reach out, and we'll see you soon. Thanks.
Whoa!